Okay, so today we're going to be talking about like terms, and this should be, again, on page 63 in your notebook. And like terms are going to be a set of terms that have the same variable, so that means the variable is the letter. Okay? Raised to the same power. So you can think of the variable, okay, as the first name and the power as the last name. Okay? So like terms can have the same variable. I mean, a pair of terms can have the same variable, but you got to be careful if they have the same power. Okay? Think of an X as a regular size candy bar and X squared as a king size candy bar. Okay? So X and X squared they're not like terms because one's just an X and the other one is X to the second. So let's determine whether these are like terms. Okay? So 2 and 3, are they like terms? Yes, they are, because they're both numbers. Okay? And 3x and 2x are like terms because they both have an x, so they both have the same variable. 4x and 4y are not like terms because this term has an x with it and this term has a y with it. So they're not like. They don't have the same variable. Okay? 5ab and 6ab, well, both terms have a and b in it, so they are like. 6x is squared and x squared. Now they both have an x in it, but one's raised to the second power and one raised to the first power. So these are not like terms. 9xy and 7yx, they are like terms because they both have an x and a y. This one just switched x and y. That's the commutative property. I can switch them around. It's the same thing. They each have a y and they each have an x. So circle all the like terms in the following sets. Okay? So the like terms would be the 5x and the negative 6x, because they both have an x with it, and of course the x. So all those are like terms. The next set of like terms would be 15 is just a number, and 3/5 is a fraction, which is also a value, a number without a variable. And then of course I can circle 1/10. So those are all like terms. Okay? So if it's just a value by itself, then you can combine it with other values set by itself. This third set of numbers, we would circle the xy, the 9yx, because that's the same thing as xy, and the negative 8xy. Those are the same terms. Okay? So each of these have an x and a y. I'm not going to circle 10x squared times y and 2x y squared because these terms are different. This term has an x to the second and this term has a y to the second. And the last set is going to be, we're going to circle the negative 5a squared times the b and the positive 3a squared of the b, because they both have an a to the squared and they both have a b. And I'm not going to circle anything else that's like, because 3ab only has one a, and then negative 8xy does not have a or b in it. So why are they giving terms like and why are we not? Okay. The 3a to the second and the 2a to the third are not like terms because they are raised to different powers. right? So even though they have an A in it, this one is raised to the second and this was raised to the third. So I cannot combine these. They're not alike. FG and 3GF, these are yes because I got an FG and a GF. They both have an F and a G. This one's just switched around. So yes, because they have the same variables. Okay. The next one is 14x and 5x. Yes, because they both have the same variable. And then 12b and 12d, no, because they do not have the same variable. They have different variables. One has a B and one has a D. So they are not alike. Okay? So as a review, like terms have to have the same variables, and they have to be raised to the same power. Okay? So that's the like terms. On the other side of your notes, now we're going to talk about combining like terms. The process of adding or subtracting like terms together. Okay? So if they're like terms, you can add or subtract them. The process of combining like terms until it is in simplest form. That is when you simplify expressions. Okay? So the rules to do this. How do you combine like terms? Okay, first of all, you want to group like terms with their signs plus or minus. Okay? You want to put a circle around the first group of like terms. You want to put a rectangle around the next group of like terms, and to put a triangle around the next group of like terms, if any. Then you subtract or add based on the sign. So for example, I have 5x, and then I got 1x, and I have 4x. They all have the same variable, so that means what I'm going to do is I'm just going to add the coefficients together and keep the x. I got 5x's, and I got 1x and 4x here. So 5 plus 1 plus 4 will give me 10x. So I'm simplifying that as 10x. So I just add them together. Add the coefficients. Keep the same variable. Okay, example number 1 or number 2. So I have 10xy and 7xy. So they're both the same because they both have an x and a y. So all I got to do is keep the same variable. The variables, xy. And then add the coefficient. So 10 plus 7 is 17. So that is going to be simplified as 17xy. Example number 2. 5x squared and then 7x squared. Notice they both have an x and they're both raised to the second power. So my variable, my like term is x to the second. Okay, so they both have the same variable and the same power. And then I just add the coefficient. So 5 plus 7 is 12. Okay. Example number 4. Okay, so I have 4x, and I can combine that with plus 3x. So I can rearrange this, and I can say 4x plus 3x and minus 8y. Okay, and the 8y would be your rectangle because that's different. So I can combine the 4x plus the 3x, which is 7x, and then I just minus the 8y. And that's it. And I leave it alone because I can't combine it any further because they don't have the same variable. Okay? Alright, so for number 1, 8y plus 1y, they both have the same variable. So 8a plus 1a is 9a. That's pretty simple. Then this one, I got to check. The x to the fourth and x to the fourth, so they're like terms. So keep the same variable with the same power, And 9 plus 5 is 14, x to the 4th. And then for number 3, I've got 7a. I don't have any other terms with an a in it, so I'll leave that one alone. Plus, well, 5c and 4c, I can put a rectangle in it because it's the second set of terms. They both have a c, so 5 plus 4 is 9c. And that's it. That's simplified because I can't combine them because they're not like terms. Okay. This one, number 4, 5s and 3s, combine them together, and I get 8s, same variable. Again, number 5, 6a to the 3rd, and 4a to the 3rd, I can only combine them because they both have the same variable with the same power. So 6 plus 4 is 10a to the 3rd. And then 5t plus 8t is one set of terms, and then the plus 4s is the next set of terms. So 5 plus 8 is going to be 13t, and then 4s, and that's simplified. Number 7, you have 10ab, 5ab, and minus 3ab, so they all have an ab with it. So all I got to do is just add the order of operations. Tells me I'm going to do 10 plus 5. So 10 plus 5 AB is 15AB. Then bring down the minus 3AB. And then I would subtract 15 minus 3, which gives me 12AB. So I could do that because they all have the same terms. Number 8. Okay. Watch, they both have the same x to the square and y, and this one has x to the square of y, so I can combine those. So I just rewrite the term that they have in common, and then I just add the coefficient, which is 4 plus 3. 4 plus 3 is 7. That's it. And then number 9, 5x goes with plus 2x, and then plus 3y goes with plus y, 1y. So 5x plus 2x, and put those together, and then plus 3y plus y, put those together. So 5 plus 2x, 5x plus 2x is 7x, and 3y plus y is 4y. That's simplified. Okay? So what I want you to do on your own is I want you to try to do the last 3 problems on your own. Number 10, number 11, and number 12, and see if you can do those on your own, and we're going to go over these the next day in class. So be prepared to tell or talk about like terms and combine like terms.